And so the unit circle is the key to trigonometry. It's extremely important for everything that we're going to do the rest of the semester. I just can't stress that enough. I've found in my experience the way that people usually have trouble with trig is that they just don't understand with how the unit circle works. And that makes sense, because if you don't understand how the unit circle works, you literally cannot evaluate trig functions. You cannot do the types of things that we need to be able to do related to trig. And so we're going to spend part of today and then most of next Monday setting up the unit circle, and it's critical. It is extremely critical that you understand this stuff. It's not terribly complicated, but it might get a little mundane. So please try to stay on top of it. If you have questions as we go, please let me know. So when I say unit circle, the words unit circle, I mean circle that has radius 1, right? Radius 1 is where the unit comes in. Right? It's a circle with a unit radius. And it looks just like this. So here's a picture of it. Right? Here's what the unit circle looks like. You can see that it's plotted on the xy axis, right? We've got x and y here. You can see that it's centered at the origin at 0. You can see here that here's the radius 1, right? This unit circle comes out to 1, 0. And that's what we think about as the initial point. We always want to think about as starting at that point on the unit circle. I'll bring that back up as we go. The first thing I want to talk about is that if we're given a point x, y, and we know it's on the unit circle, then we know x squared plus y squared equals 1. In other words, if you're given a single value, and you know it's on that both points are on the unit circle, then we can find the other one by just plugging it into this equation and solving. Like for example, if the point x, minus 1/3 is on the unit circle, find the x-coordinate given that the x-coordinate is positive. And so this is just telling us a point. We can take this point and plug it into this equation and find the other one, right? And so since x squared plus y squared equals 1, we can plug in x and y and solve for whichever one we're missing. So in this case, we're missing the x, right? But I have a y value. And so I'm going to take that y and plug it into the equation and solve for x. And of course, when I square minus 1/3, it makes it positive, right? And we get x squared plus 1/9 equals 1. And then we can just subtract the 1/9 over to the other side, get x squared equals 1 minus 1/9, which is 8/9. And then we can take a square root. Right, we take a square root and we see that x equals plus or minus the square root of 8/9. And so if the y value is minus 1/3, the x value is either plus 8/9, square root of 8/9, or minus square root of 8/9. And we're being told in the problem the x coordinate is positive. And so since x is positive, we're being told since x is positive, that implies that x equals plus square root of 8/9. And we can simplify that if we wanted to, right? This simplifies into 2 root 2 over 3. How did I get that? How do you simplify that square root of 8/9 to 2 root 2 over 3? What do you do there? This is from the radical section, remember? Yeah, so you can break up the 8 into 4 times 2, and then you can take the square root of 4 and pull a 2 out. And then you can just take the square root of 9 to get the 3, right? So this simplifying that is from the very first section we covered. And that's not super important for these problems, but I just want to point that out. Other questions about that one? The other one's very similar, right? So we're being told that the x-coordinate is minus 2/5 and the y-coordinate is above the x-axis. That means that the y-coordinate's positive, right? And so we're given the point minus 2/5 comma y, and we can figure out what y is. So we do the same thing. Minus 2/5 squared plus y squared equals 1. And so then we can just solve for y, right? So 2/5 squared is 4 over 25. And then we'll get y squared equals 1 minus that. And so we get y squared equals 21 over 25. And then we take a square root. And we get y equals plus or minus square root of 21 over 25. And which one is it? Is it the plus or the minus one? It's the plus because we're told that y-coordinate is above the y-axis, right? So we say since y is above the x-axis, this implies that y is positive. And so we use the positive version. Can we simplify 21 over 25 at all? What can that simplify into? Yes, we can take the square root of 25 and get 5. 21 can't be broken down anymore, right? 7 times 3, neither of those are perfect squares. 21 is not a perfect square, so we can't do anything else. So that's the first type of problem you might see. Just kind of introducing what the unit circle is. If we have one point on the unit circle, we can figure out what the other point is by just solving. But the real main point here is to never forget, this is what the unit circle looks like. It's a bunch of points that are being plotted in the Cartesian plane, and it has the equation x squared plus y squared equals 1. Right? That's kind of the main point of what you should be getting away from this so far. Taking away from this, I mean. Questions at all? The other thing I want to introduce right now is how we move around the outside of the unit circle. And so let t be a distance on the unit circle. If t is some positive number, that represents walking counterclockwise around the unit circle. And so if your page isn't in color, you might have a hard time seeing this. But if t is positive, like in this picture, then that means we're starting at that initial point and we're walking counterclockwise around the circle in this direction, right? Counterclockwise. Right? Start here and we walk counterclockwise. If t is a negative value, that means walking clockwise. So that would be starting at that same initial point and going clockwise around it, like in this picture. Right, you can see in this picture here, the t is negative, and so we're starting here and we're walking counterclockwise. And the entire next page, what we're going to do, just kind of looking forward here, we're going to take different step sizes around the unit circle. These are going to be walking along the outside of these unit circles, right? We're going to kind of like take steps around the outside at different increments. And each one is going to be represented by a t value. Now, when we walk along the outside of the circle, we're going to end up at some x comma y. It's going to be some point. And we call that the terminal point. So for example, the entire circumference, well, we know what the formula for circumference is, right? It's 2 pi r. and r in the unit circle is 1. Right? R is 1 in the unit circle. That's why it's the unit circle. And so that means the circumference of the unit circle is 2 pi times 1, which is just 2 pi. And so that's what this rightmost picture is showing us. If t is 2 pi, that means you start at this initial point, and you walk all the way around the outside of the circle, and you end up back at the same spot. That's why this entire thing is red, because we walked all the way along the outside. 3 pi over 2 is 3/4 of the way around. So that would be starting at the initial point and just walking 3/4 of the way around. And you can see that we would end at the point 0, -1 in that case. Halfway around the unit circle then is pi. Right? If all the way around is 2 pi, then halfway around is half of 2 pi, which is 1 pi. And you can see that we end up with the terminal point -1, 0. And then lastly, if we just take a step of pi over 2, that's just walking 1/4 of the way around the unit circle, and we end up at the point 0, 1. Right, so these are like really basic values, and the first thing I'm going to show on the next page are these exact values. And so I'm just going to show the very first one, and then we'll call it a day here. Other questions about this page before I do that? Okay. So on this page, these are like the 5 main points that you need to know. And what we're going to do on all these subsequent pictures is we're going to build up these points and how we actually obtain them using the unit circle. Okay? And so for example, if our increment is pi over 2, that's like starting here. We always think about starting here. And we think about that as t equals 0, because we're not moving. And it has the terminal point 1, 0. If we take a step of pi over 2, that's like starting at that terminal point, or the initial point, I mean, and walking 1/4 of the way around the unit circle to right here. So that distance I just drew out, that's a distance of pi over 2. And so this is given to us by t equals pi over 2. And you can see that we end up at the terminal point 0, 1. Right, this is the point right here on the unit circle, 0, 1. See how this point is this point? And you can see it's given by pi over 2. If we take another step along the unit circle of pi over 2, it would go from here to right here. Okay. This is the point t equals pi, because we took 2 steps of pi over 2, right? Pi over 2 plus pi over 2 is pi. 1/2 plus 1/2 is 1. And that has the terminal point -1, 0. And again, this distance that we just walked is distance of pi over 2. If we took another step of pi over 2, we'd go from that point to right here. Right? That would be another pi over 2 step. And that would take us to the terminal point 0, -1. And we took 3 steps of pi over 2, right? 3 steps of pi over 2. That can be written as t equals 3 steps of pi over 2. Does everyone understand that that's what 3/2 pi means? 3/2 pi is 3 steps of pi over 2. And then if we took another step of pi over 2, we'd be back at the beginning where we started. So it takes 4 steps of pi over 2 to get all the way around the unit circle. And in doing so, we hit all these terminal points along the way. So again, we walked around on increments of pi over 2,
And now we're going to take smaller and smaller steps, right? So we'll take a step of pi over 3, and then down here we'll take a step of pi over 4, down here we'll take a step of pi over 6. And what this is showing us in the top here, this is going to be kind of the summary of what we're going to end up seeing. But what the sort of the main thing to take away from this top part is that these are the 5 key distances and corresponding points. So these are the 5 key distances and terminal points that we really care about. All right, and we'll see that these are the points that we're going to end up finding as we walk along the unit circle. Okay, so, and I know they look confusing. They look like fractions, and they are, they're radicals and all kinds of things, but they're actually not that complicated once we dissect it. But we'll get into that as we go here. I'm going to take a second and just zoom pi over 3 around the outside. We always start right here. Okay, this is our t equals 0 spot, or 2 pi, but we'll start at 0, right? If we take a step of pi over 3, that's 1/3 pi. So that's, if this is pi over here, then 1/3 between the two of them would be from here to here. All right. So this distance that I just drew right there, that's a distance of pi over 3. And so that is the point t equals pi over 3. And as we look up here at these points, you can see that pi over 3 is associated with points that look like this. It's associated with points that look like 1/2 comma square root of 3 over 2. And so that's what this point is right here. This is the point 1/2 comma square root of 3 over 2. All right, that was our first step along the unit circle of pi over 3. If we take another step, it would be from that point to right here. This is another step of pi over 3. So this, again, this distance right here is a pi over 3 distance. And so that was our second step of pi over 3. And so we write that as t equals 2 pi over 3. Right, does everyone see that 2 pi over 3, you can interpret that as 2 steps of pi over 3, right? Or 2/3 pi is the other way to think about that. It's 2/3 from 0 to pi. Like if we just look at that visually, that point right there is 2/3 between where we started and this point right here, which is pi. And so that has the same terminal point. We want to use the terminal point 1/2 square root of 3 over 2, except the x value is now negative and the y value is still positive. Why is that the case? Why do they have, so they have the same, the same sort of general form because they're both pi over 3s. But why is the x value now negative? Someone explain that. Kayla? Yeah, we always want to remember that we have the x and the y axis here, right? Like I'm putting my pens on the x and the y axis. And so this middle point is 0, 0. And so this point right here is to the left of that and up. If we go to the left, that's negative x values, and up is positive y's. And so that's why this one has a negative, and this one stays positive. With me on that? Let's take another step of pi over 3. So another pi over 3 step would be our third step of pi over 3. And so we'd be down here at pi, right? Because this is t equals 3 steps of pi over 3. Notice that those two 3's cancel, right? 3 steps of pi over 3. And so that's the same thing as just pi. Right? 3 pi over 3 is just pi, because again, that fraction reduces into pi. And we already know from this previous exploration that at pi, we get this terminal point, minus 1, 0. Right? So this one has the terminal point minus 1, comma 0. And we've already seen that one. Is that okay? I'm trying to go particularly slow on this first one. I want to make sure that is clear. And if it's not, just say so. I can repeat something. You can tell me what's wrong. You can just say that doesn't make sense, and I'll try again. Like, any of that stuff is helpful. Is that all right? All right, we'll take another step of pi over 3. So another step would take us down to here. Right, so the distance between those 2 points again is pi over 3. And that was our fourth step. And so this is 4 steps of pi over 3. Right, 4 pi over 3. And it's got the same terminal point, 1/2 square root of 3 over 2, except now we're down here in the fourth quadrant, or the third quadrant, excuse me. And in the third quadrant, everything's negative, right? It's like we went to the left and down. And so negative x, negative y. And so this is going to have the point minus 1/2 minus root 3 over 2. And we're almost home, right? Another step of pi over 3 would take us to here. So that's our fifth step of pi over 3. And so that's going to be t equals 5 pi over 3. And now in that point, this is the fourth quadrant now, right? And so x values are positive and y values are negative there. And so this is going to be positive 1/2 negative root 3 over 2. And the last step would take us home. I don't know why I'm using the word home. It would take us back to the start. Right, the next step would take us back to the start. And so that's not only t equals 0, this kind of goes back to Jason's point before. That's also 6 steps of pi over 3. And we can reduce that fraction, 6 over 3, right? 6 over 3 is 2. And so that's the same thing as 2 pi, right? So it takes us back to the beginning, which is 2 pi or 0 or 4 pi or 6 pi. There's lots of different things that would put us on that one point. But I'm just trying to point out that 6 steps of pi over 3 puts us on that point the same way that 2 pi puts us on the point, the same way that 0 puts us on that point. Okay, and I didn't write down the point, so I might as well. That's the point 1 comma 0, right? All right. Questions? I'd love to hear a question. Let me just keep talking for one more second while you're formulating that question. Notice that if I connect the dots between all the pi over 3 ones, so I'm skipping over the x-axis ones, but if I connect the dots between all the pi over 3 ones, it makes a rectangle in the middle. And so that's showing us that like these 2 points have the same x value. See how they're connected by a straight line? And so that's why those 2 points both have the x value 1/2, right? They're the same. Similarly, these 2 points that I'm now connecting, right, those two have the same y value. You can see that they have the same height. And so you can see that they both have positive square root of 3 over 2. The only difference is that the x values are positive or negative. Right? Similarly with those two line up with each other, and so those two have the same x value. Right? These two line up with each other, so they have the same y value. But they all have the same general form. They're all plus or minus 1/2, comma, plus or minus square root of 3 over 2. I really would like to answer a question, if you have one.
So how do you know how, like, does it matter where we put the dot depending on the lines, right? Like, how do you know how to move? Like, do we just go by, like, if it's pi 3, we move by 3?
Yeah, so maybe it would help if I looked for like what's the point of this? Maybe I should have started there. Thanks for bringing that up. And let me know if this answers your question or not. What I'm trying to do right now is I'm trying to build the unit circle and what the unit circle looks like. And so if you look in 3 pages from now, we've got a completed unit circle. 3 pages from now, it looks like this. I'm zoomed in, so you can't really see it, right? But I'm trying to build the intuition behind this unit circle, the completed unit circle, and where those points came from. Okay? And the reason I'm doing that is because if you look in 4 pages from now, all the trig functions are based on the unit circle. So just for example, if I want to know what cosine of pi over 3 is, I would think about where pi over 3 is on the unit circle, and then cosine happens to be the x value. And so cosine of pi over 3 is 1/2. Sine of pi over 3 is square root of 3 over 2, because it's the y value. And so, again, we're going to get to this on Wednesday, but like the whole point of this is because trig functions, the value of trig functions, are these x and y values on the unit circle. And so right now there's not really like a rhyme or reason to how we're stepping. I'm just trying to step at different increments and show you how the unit circle is kind of built. Does that answer that question? Okay. Other questions? Those are good questions, keeping me on my toes, making sure I'm explaining things. I did not do a good job explaining that initially, so that was good. Is there anything else that's not clear at this point? All right, let's do the next increment then. So pi over 4 is the next one. It's a little bit smaller, right? It's 1/4 pi. And so we're going to do the same thing. I might bust out another color here because we're going to have a few more points. But anyway, we're still thinking about starting at this same point, right? This is our t equals 0 point. Any point that we hit right now that we've hit before, I'm just going to not write the point down because we're going to run out of room basically. So this, we already saw this point. We saw this point right here. It's the point 1, 0, right? So I'm not going to write that down, but just know that we already saw that one. If we take a step of pi over 4, that's 1/4 pi. So that's 1/4 from here to here. And so that would be right here. That's where pi over 4 lives. T equals pi over 4 is that point right there. And just kind of based on the unit circle and the way it looks, and also based on this table up here, we can see that pi over 4 has this point associated with it. And this is the kind of, it's a nice one because the value repeats itself, right? Square root of 2 over 2, comma, square root of 2 over 2. And so that's the point that's associated with that first pi over 4 value. It's square root of 2 over 2, square root of 2 over 2. And so anytime we have a fraction that ends where the denominator is a 4, it's going to have some version of square root of 2 over 2. And we just change plus or minus depending on what quadrant we're in. Okay, so if I take another step, it would take me right to the y-axis. Right, it would take me right here. We've already seen this one, but just to be clear, this is my second step of pi over 4, right? 2 pi over 4. 2 pi over 4 is a fraction that can be reduced. 2 and 4 go into each other, right? Or 2 goes into 4, I should say. And that can be reduced into pi over 2. Right? So we already knew that that point was pi over 2, and I'm just showing you that it's also the same thing as 2 pi over 4. Right? We saw that one on Monday. That's this point right here, pi over 2. See that? And so if we just reduce that fraction, we see it's the same. See what I'm saying about that? So 2 pi over 4 is the same thing as pi over 2 is what I'm saying. If we take another step of pi over 4, it would take us from right here to right here. And so that's my third step of pi over 4, right? And so this is 3 pi over 4. Again, 3 steps of pi over 4. That's how I like to think about it, at least, right? Or 3/4 pi, if you will. And so that's going to have the same kind of form of a point, except we're in quadrant 2 now. And so if this is 0, 0, we went to the left, so negative x values, and up, positive y. All right, so this has got the point minus root 2 over 2, positive root 2 over 2. Right, because we went to the left, negative, up, positive. Is that all right? The next step will take us back to a point we've seen before, right? And just to be clear, this is pi. We know that's the point t equals pi, but it's our 4th step of pi over 4. And so we can see that it's also pi because those 4's cancel out. And the 4's cancel and we just get pi, right? And so we've already seen that point. And so I'm not going to write down the point. But what point is it? What's the xy value there? It's minus 1, 0, right? It's this point right here. It's minus 1, 0. We've already seen that one. It's right there. All right, another step of pi over 4 would take us right here. So that's my 5th step of pi over 4. The other way to think about that is it's pi over 4 past pi. Right? If it was 4 pi over 4, we'd be at pi, and so 5 pi over 4 is 1 step of pi over 4 past pi. Right? So that's how we can get to right there. And now we're in the fourth quadrant where everything's negative. Right? If this is 0, 0, we went to the left, so negative x, and down, so negative y. And so we've got negatives on both of them. I'm just going to pause here. I feel like either I'm just such an amazing teacher that like you guys are just getting this. It's just so good. I'm just making it obvious. Or I don't know, I'm going too fast and not giving you enough time, or someone wants to say something but they're really hesitant. I don't know why you're doing that, right? You want to ask a question, makes us better learners. So can I answer something? Yes.
Why not 5?
Why not 5 what? Pi over 5? That's a good question. Why do we only use these particular ones? It's because these these radians, so the question was, just to be clear, why are we choosing these increments? Pi over 2, pi over 6, pi over 4, pi over 3. Oh, so it looks like 3, 4, 6. So why are we skipping over 5? That's really what you're pointing out. Yeah. These particular radian measurements correspond to interesting degree measurements. And so that's what we'll see in a future section, is that pi over 3 is the same thing as 60 degrees. Pi over 4 is the same thing as 45 degrees. Pi over 6 is the same thing as 30 degrees. Like, as in like a triangle 30, 60, 90. And so these correspond to common degree measurements. Yeah, that's a good question. Other questions? All right, let's finish this one off then. So another step of pi over 4 would take us down here. And so that's our 6th step of pi over 4. So this is 6 pi over 4. Right? And that's a fraction that can be reduced. Both of those numbers are divisible by 2. And so that's the same thing as 3 pi over 2. And so we can literally see it's this one right here, right? It's 3 pi over 2, because 6 pi over 4 can reduce into that. So I'm not going to write down that point because we already wrote that one down. Our penultimate step here takes us to right there. Right, that's another step of pi over 4. And so that is our 7th step of pi over 4. And we can see that we are now in the quadrant 4. And in the 4th quadrant, we have positive x values and negative y's. And so this is positive square root of 2 over 2, negative square root of 2 over 2. Right, positive x, negative y, because we went to the right and down. And then the last step would take us back to the beginning, right? And just to be clear, it takes us back to the beginning because it's our 8th step of pi over 4. 8 pi over 4 reduces into 2 pi. Right? 4 goes into 8 twice. And so that's why 8 pi over 4 is the same thing as 2 pi, right? It takes us back to the beginning. I didn't write down any distances, so I'll just write down one, right? Every one of these steps, in between every one of those dots, is a pi over 4 distance. So every time we took a step, it was a distance of pi over 4. So keep that in mind for the next page. We'll need that kind of information on the next page. Questions about this, though? This page is a little bit grueling. Got one more to do, and it's the smallest step size. So this next one's going to be really filled up, and we're going to end up hitting a lot of the ones we've seen already. But notice on this one, again, like if we connect the dots between all the pi over 4, all the ones that have a 4 in the denominator, all the distances, it again makes a rectangle. It's actually a square in this case. And we can see that they all have the same similar x and y values because they line up with each other, right? Things on the top have the same y values. Things down here on the bottom have the same y values. And then on the right, they have the same x values, and on the left, they have the same x values. Again, because they line up with each other, right? Any questions before we do the last one? I'm just curious, how many people remember this kind of stuff? Okay. If you don't, it's no problem. I honestly didn't, I didn't remember this stuff after I, if you don't look at it for a while, you just don't remember it after a while, right? I don't remember when I re-remembered it, but anyway. I should probably not say that anyway since I'm being recorded and I don't need that kind of stuff on record. So if we take pi over 6 steps, it's the smallest step, and so we're going to end up hitting a lot of these other ones, right? And so the first step would take us to this first point right here. That's pi over 6. So first of all, we started at 0, of course. That first step takes us to pi over 6. And you can see, looking at the top here, pi over 6 has this point associated with it. Square root of 3 over 2, comma 1/2. And so even though these points, this is a good time to point this out, even though all these points are nasty looking, they're fractions and there's radicals, the pi over 4 one repeats, and so that one's not too hard to memorize. And then the pi over 6 and the pi over 3 are just opposites of each other, right? This is square root of 3 over 2, 1/2, and this is 1/2 comma square root of 3 over 2. So they're like opposites of each other, and so there's really only 3 numbers you need to memorize. Square root of 2 over 2, 1/2, and square root of 3 over 2. It's just those 3 things. I know it looks like more, but it's really only those 3 numbers that are differing in there. But anyway, we're doing the pi over 6 ones, and so we're using this form, square root of 3 over 2, comma 1/2, and so that's what this first one has. All right, this has the point square root of 3 over 2, comma 1/2. If we take another step, we hit something we've already seen before. All right, so our next step would take us to this point, and that is 2 pi over 6. And that fraction, 2 pi over 6, is the same thing as pi over 3, because the fraction reduces into pi over 3. And we already saw that one above. All right, so I'm not going to write that point down. But I know that 2 pi over 6, since it's the same as pi over 3, is going to be this point. 1/2 square root of 3 over 2. Is that okay? So we're going to end up hitting all the pi over 3 ones on this one, right? Because pi over 6, or pi over 3 is a multiple of pi over 6. Shown by this. Anyway, we'll see that as we keep going. Our next step would take us to the y-axis. Take us to right here. And so there's a couple ways we can think about this one. This one is our third step of pi over 6. 3 pi over 6 reduces into pi over 2. Right? 3 goes into 6 2 times. And so that's why this point is pi over 2. Right? 3 pi over 6 is the same as pi over 2. All right, our next step would take us right here. This is a new one. Oh, no, this is not a new one. This is not a new one because this is our fourth step of pi over 6. And 4 pi over 6 reduces into 2 pi over 3, right? 4 and 6 are both divisible by 2. And so this is 2 pi over 3. And so we've already seen that one as well. Right, we saw that one right here. Our next step is a new one, though. The next step, which takes us right here, that is our 5th step of pi over 6. So 5th step of pi over 6 means 5 pi over 6, or 5/6 pi. And we can see that it's going to have, since this can't be reduced, right? You can't reduce this fraction. So it's going to have a form that looks like this, square root of 3 over 2, comma 1/2, except the x value is negative and the y value is positive. The next step would take us back to the x-axis. We've already seen that one, but I'll just write it down anyway. This is our 6th step of pi over 6. And so 6 pi over 6 reduces to just pi. All right, this is a brutal one. There's a lot of steps here. We're only halfway done. But maybe I'll pause right now because there's a lot going on in this one. Let everyone catch up for a second. Can I answer any questions right now? All right, let's keep going then. Our next step would be right here. So that's our 7th step of pi over 6. I can't believe we've taken 7 steps, but we have 7 steps of pi over 6. So 7 pi over 6, in other words. So that's the point. We're going to use that same form, square root of 3 over 2 comma 1/2, but negative x, negative y, right? They're both negative. We take another step, takes us down here. We've already seen that one before, so we won't spend time there, but that's 8 pi over 6. That's our 8th step of pi over 6. And we know that we can reduce that into 4 pi over 3. Right, both those numbers are divisible by 2. Our next step is also familiar. Our next step would take us back to the y-axis. And we know that's familiar because that's our 9th step of pi over 6. Yes, we have taken 9 steps of pi over 6. Both of those numbers, 9 and 6, are divisible by 3. And so that's the same thing as 3 pi over 2. And we've already seen that one. We saw that one on Monday, right? That one's right here. All right, we're in the home stretch here. Let's take a couple more steps. Our next step would take us right here. That is our 10th step of pi over 6. And we know that 10 and 6 are both divisible by 2. And so this is 5 pi over 3. And we've seen that one before. Our last new point is the next step. The next step would take us right here. All right, that's our 11th step of pi over 6. We can't reduce this fraction anymore, right? You can't reduce 11 pi over 6. And so since we can't reduce that fraction, that's an indication that it's a pi over 6 type. And so it has square root of 3 over 2, but the y value is negative because we went to the right and down, right? So positive x, negative y. And so we get that. And then, of course, the last step takes us back to the beginning. And just to be clear about that last step, that's 2 pi because it's 12 steps of pi over 6. 12 over 6 is the same thing as 2. Whew, okay. What a grueling page. But notice, again, if we connect the pi over 6 dots, all the pi over 6 dots, they make a rectangle, which is why they all have the same form, square root of 3 over 2 comma 1/2. We just change plus or minus depending on what quadrant we're in.
That's the same rectangle as that when it's flipped. Like a certain some number of degrees.
Yeah, that's a good point. So
90 degrees.
yeah, it's flipped 90 degrees. So the point is, Rachel's making the point that this rectangle here is the same as this rectangle, but it's been turned, right? If we took this and we turned it sideways, we took it and we turned it like that, it would look like the pi over 3 one. And notice that the points are the same too, they're just switched. There's 1/2 comma square root of 3 over 2 compared to square root of 3 over 2 comma 1/2 for that same reason. Things got like translated. You want to say something else? Yeah.
So then a 12 would be close to 45 degrees.
I'm sorry, say that again?
So like a 12 would be 45 degrees.
Oh, if we had like pi over 12?
Would that be like 45?
No. Because if we turned it 45 degrees,
Well, not like how much it's turned, but just relative.
maybe. I don't think, no, not pi over 12. It would be what's in between pi over 3 and pi over 6, which is Off the top of my head, I don't know what that is, but it's not pi over 12. But you're right about that. Yeah, that's a good observation. It's a good visual observation. Visual learner? You like visual stuff? Graphs and stuff? Someone else had another question? I thought there was another hand.
Yeah, I kind of did. I was trying to or whatever. What did that mean again?
The area? Are you talking about the
Yeah,
the area?
of the circle.
So the area of a circle doesn't apply too much to this, but the circumference does.
Yeah, that's not what I was like thinking of, just because it's like, oh, you're really just like taking the diameter because the radius is 1.
Right.
So like 1 technically just is still there, like you're timesing pi by 1, which is the radius.
Yeah. So I don't. Maybe you don't remember this anyway. What we had talked about on Monday is that the circumference is 2 pi r.
Alright, that's good.
And r is 1 in this case, since we're on the unit circle. And so that's why the entire outside is 2 pi. And because we're using that formula, and we realize that the radius is 1, so if we walk all the way around the outside, that's why we get 2 pi.
Yeah.
Yeah, that's right. That's good stuff. Other stuff? Glad you're thinking about this stuff. Questions, comments like that? Those are mostly just good comments, but I'm happy to field some questions too. Anything? Okay, so that's like the intuition behind why the unit circle have the points that it has. And so we just built this entire unit circle. If you look in a couple pages from now, right, this entire unit circle that's in a couple pages, we just built this all up. And we have this. And so this is a good reference page. I'm going to be referencing this page a lot. You might want to just kind of have it handy. We don't need it yet, but just in general, that's a good page to have on hand. Okay. Other questions before we move on? Start using this stuff a little bit? Okay. So let's talk about the concept of a reference number. It's kind of like the idea of, it's very similar to the idea of reducing fractions. And so I'm going to keep zoomed in here because we'll need it in a second. But the idea is, if we have some t value that we want to explore, the reference number, which we call t bar, I don't know if you can read that very well, but it's the letter t with a bar written over the top of it. I will refer to that as t bar, although you'll hear I often say t hat. I don't know why I can't just get that out of my head. I like to say t hat, but t bar is the proper way to say that. Anyway, the reference number t bar is the shortest distance along the unit circle between the terminal point that's given by t and the x-axis. Okay? And so let me just show you one and you'll see what I mean. And when I say terminal point, I mean whatever x comma y we end up with. So when you're given a t, like this one right here, if we want to find the reference number for 4/3 pi, or 4 pi over 3, we find out where 4 pi over 3 is, and then we measure how far that is from the x-axis. So 4 pi over 3 is taking 4 steps of pi over 3, right? And so we're starting at that point, and we're taking 1 step. That's 1 step of pi over 3. 2 steps would be to there. 2 steps of pi over 3. I'm going to be trying to be very explicit about these first couple. The third step of pi over 3 is at pi, right? 3 pi over 3, or pi. And so the fourth step would be down here. This is where t equals 4 pi over 3 lives. And we went in this direction, just to be clear, we went in the counterclockwise direction because this is a positive number. Just kind of looking ahead in 1 second on the next one, see how the next one is negative 7 pi over 6? That means we're going to go clockwise instead. Right, so we went counterclockwise because this is a positive number, and we walked 4 steps of pi over 3, and we ended up right here. Is that okay? Okay. The reference number is the shortest distance from this point to the x-axis along the outside of the unit circle. And so the t bar is this distance. So t bar is the distance from where we ended up at 4/3 pi along the perimeter to the x-axis. And again, it's the distance that I'm highlighting in red here. We're trying to think about how far is where we ended up from the x-axis along the outside of the unit circle, along the perimeter. How far is that? Anyone? Kayla? I'm sorry, I couldn't hear you. Yeah, it's one step of pi over 3 away, right? From the start of that red line to this end of this red line, where we ended up, is a step of pi over 3. Yeah, if it was over here, we would go the other way. Yep, just the shortest distance, whichever one's closer, yeah. And so that distance right there, it was one step of pi over 3. And so that means our reference number, t bar, is 1/3 pi, or pi over 3, however you want to think about that. Either one is fine. It's the same thing. And the reason we want to know that is because in situations like on the previous page, like when we ended up with something like, I don't know, like this one, for example, when we did 4 pi, if we wanted to know 4 pi over 6, you might get tricked by thinking that this is a pi over 6, but it's really a pi over 3 version because the fraction reduces, right? And so if we wanted to know what the point is associated with 4 pi over 6, we measure the distance along the outside of the unit circle and realize that it's a pi over 3 distance, really, not a pi over 6 point. And so the point of this is I'm trying to force you to think about the reduced version of the fraction. That's really what I'm trying to say. It's kind of a complicated way of just saying you need to reduce the fraction when you think about this stuff. Are there questions about this first one? We're going to look at a couple more. And then I'm hoping it'll really make sense on the next page. All right, let's look at the next one. So on the next one, let's find the reference number for minus 7 pi over 6. And so again, since it's a negative now, this means we do what? Yeah, it means we go clockwise. So we move clockwise instead of counterclockwise. And we're going to take 7 steps of pi over 6 in the clockwise direction. And so we start there. We take 1 step, which takes us down here. I guess I'll write them out. This is minus pi over 6. The second one is minus 2 pi over 6. The third one is minus 3 pi over 6, which is the same thing as minus pi over 2 if we wanted, right? The next one would be minus 4 pi over 6. How many are we doing? Oh, 7. Got a couple more. The next one would be minus 5, minus 6, and then finally we'd end up right here, minus 7 pi over 6. Is that okay first? All right, it was negative, so we moved clockwise. We took 7 steps in a clockwise direction, and it took us right there. And so we want to know what this distance is. This is what t bar would tell us. T bar is that distance. It's the shortest distance from minus 7 pi over 6 to the x-axis. How far is that? It's a pi over 6, right? We took 1 step of pi over 6 past that. And so this is positive pi over 6. Is that okay? Yeah.
Would the t-bar ever be negative?
Yeah, that's a good question. We're always thinking about the t-bar as being positive. It's really it's just a reference. So we reference whether or not we're talking about a pi over 6, are we talking about a pi over 4, or a pi over 3. So it doesn't really matter whether it's plus or minus. It's just trying to make us think about what point are we thinking about. Are we thinking about the square root of 2 over 2, comma square root of 2 over 2, or are we thinking about the 1/2, comma square root of 3 over 2? It's just trying to direct us towards which one of these groups of points are we trying to think about. Is it one of these, one of these, one of these, one of these? And this one is a pi over 6, and so that point is going to be one of these type of points. That's the whole point of this. Other questions? There was another hand back there. Devin, do you have something you wanted to add?
I think I was gonna ask the same thing.
Okay. Yeah, so even though we went, well, first of all, we're still going counterclockwise there if we wanted to know that distance, so it would still be positive. But the whole point is just that we're recognizing this point as a pi over 6 type point. That's the big takeaway. Other comments? This next one looks a little strange compared to the ones we've seen so far, right? 17 steps of pi over 4. 17 pi over 4. So you're welcome to think about walking along and taking 17 steps. That's kind of annoying, right? So think about this as, how many times does 4 go into 17? Goes in 4 times, and then there's 1/4 left over. So 17 fourths, 17 pi over 4 is the same thing as 4 1/4 pi. Is that okay? I already saw Eric doing it, right? This just means if 2 pi is going around once, then 4 pi means going around twice. And so we're going all the way around twice, and then another quarter step. All right, so let me write that out. 2 pi would be going all the way around 1 time, right? That's 2 pi. 4 pi would be doing it again. And then we're taking an additional pi over 4 step. And so that would take us to right here. You with me on that one? We went around the unit circle twice, and then an additional 1/4 pi. And we're going in the counterclockwise direction because it's a positive number. Is that all right? So this point right here is 17 pi over 4. What's t-bar in this one? It's this distance right here. What's that? Yeah, and so this one has t-bar equals pi over 4. And again, what we'll see on the next page is that means the terminal point associated with this one looks like a pi over 4 type terminal point. All right, so in other words, we don't have to memorize the unit circle. We just kind of understand how the unit circle works, and then we figure out what the point is because we know what pi over 4 type points look like. That's what we're building this up to. Oh gosh, I was like, what is going on? I was thinking this class ended at 15, so I was like, all right, we got 15 more minutes. And I'm looking here and I'm like, what? We do have 15 minutes. Anyway, sorry. That just really confused me for a second. Okay. For a second, I thought I would kept you 15 minutes over. And I was like, oh, shoot. Anyway, sorry. Just my own brain working here, or not. But anyway, let me just remind you how this one worked. This worked because this terminal point is 0. I'm sorry, this initial point is t equals 0. It's also t equals 2 pi, and it's also t equals 4 pi. And so going around 4 1/4 times just means we stayed there, basically, and went another quarter past it, quarter pi. Is that all right? All right, take a moment and do this last one then. What's the t-bar for this one? All right, what's minus 5/3 pi? So remember that this means go clockwise because it's negative. So you want to take 5 steps of pi over 3 in the clockwise direction.
And practice is particularly important on this stuff. You know, you'll see very quickly in the next section. This is like the first step in doing trig problems, is knowing where the point is on the unit circle. And so you don't want to spend too much time counting and thinking and trying to write the point down. Eventually that you should be able to come up with that stuff fairly quickly, I guess is what I'm trying to say. And that's where homework comes in and practicing this stuff. Okay, so when I look at this one, I'm going to take 5 steps of pi over 3 in the clockwise direction. So 1 takes me right here, 2 takes me right here, 3 takes me right here, 4 takes me right here, and 5 would take me right here. So that's 5 minus 5/3 pi, or 5 pi over 3. And so what's the t-bar associated with that? What's this distance right here? That distance is a distance of pi over 3, right? All right. That's how reference numbers works. Can I answer any questions about it? Yeah. Yep. That's okay. Go ahead.
And the 10 comes around, if we know that the circle's 2 pi, whatever the number, like 6 over 3 is.
Yeah, so what you're pointing out is minus 5/3 pi is one step less than minus 6 pi. And so yes, that's eventually what you want to start thinking about. Like, you don't have to count out 5 steps. You think, oh, it's 1 less than going all the way around. If I went all the way around, it'd be here, so I go 1 less, which is right there. Yeah, that's how you want to start thinking about this stuff. The other way to think about that is, it's 2 steps past minus pi. Right, minus 3 over 3 would be minus pi. So you can already just start right here in that case and take 2 steps further. 1, 2. So yes, absolutely start thinking about, rather than counting out the steps, how close is it to something that's very easy to figure out. Yeah. Right, like on this last one, what you might think is, that's how I was trying to get you to think about this, is 1/4 past 4 pi. And so just know that 4 pi is keeping you there, and just take 1/4 more. Yeah. Great. Other questions or comments? We're going to put this all together on the next page. So far we've been building everything up to the next page. The next page is the real important page that's going to kind of drive the rest of the semester. I mean, it's all important. It's all building on each other. But anyway, the next page is where it's at. Can I answer any questions about this page right now? All right, next page. Let's do it. This is it. So using the reference number to find terminal points. And so like I wrote at the top here, if we combine the concepts we just saw on the previous pages, we can find the terminal point given any number we want. We just do the following 3 things. You think about the reference number. So that's what we just did on the last page. Right? In other words, you think about what the terminal point is associated with that. You find that terminal point. That's 2 pages ago. And I feel like I've already kind of been working this into the lecture already, but you're going to have a point that's going to be plus or minus something, comma, plus or minus something. And then you choose the plus or minuses based on whatever quadrant we're in. Right? So that's the kind of talk I was using when we were doing the first page. So let me do one and make sure this makes sense here. I'm going to write out the steps. You don't need to write out the steps if you're doing homework or a test or anything. Quite frankly, you need to get to the point where you don't need to write out any steps. You just kind of say, oh, 7 pi over 6, I know that has this point, right? That's eventually where you want to be able to get to. Well, let's build it up a little bit. Okay, so 7 pi over 6. That's 7 steps of pi over 6, right? And so if I took 7 steps of pi over 6, I'd go 1, 2, well, let me do it this way first. 2, 3, 4, 5, 6, 7. So that's 7 pi over 6. What's an easier way to think about that, Rachel?
Pi plus 1.
Yeah, it's 1 pi over 6 past pi. Right? If it was 6 over 6, it'd be at pi right here. And so 7 over 6 is 1 past that, which would be here. And so that's a nice shortcut way to get there. All right, so we want to know t-bar, the reference number, this distance. This is what t-bar is. What is that distance? Just regular pi over 6, not plus or minus. The reason that we don't really care is because we just want to know the type of point that it is. And so t-bar is pi over 6 in this case, and so that tells us that our point looks like this. It's got to be square root of 3 over 2 comma 1/2 in some form, plus or minus, depending on where we are. So the whole point of doing this first step is so that I know that my terminal point is going to look like this, square root of 3 over 2 comma 1/2. All right, so let me just write that down. I'm going to be very careful about this first one. We know that pi over 6 has the terminal point plus or minus square root of 3 over 2, comma, plus or minus 1/2 from that first page that I just put up there. Step 3 says pick plus or minuses based on where we are. We're down here in quadrant 4. In quadrant 4, x values are negative because we go to the left, and y values are also negative because we go down. And so we know we choose the negative versions, right? And let me write that out then. So 7 pi over 6 is in quadrant 4. Actually, it's 3. I'm sorry. Misspeaking here. It's in quadrant 3. And in quadrant 3, both values are negative. Both x and y values are negative. And so based on that, 7 pi over 6 has the terminal point minus root 3 over 2 minus 1/2. Let me write that down, see if it makes sense. Kill? Because if it's a fraction that reduces, then you want to make sure you're thinking about the correct form. So what do you mean you can do it without doing that?
Because it's in the, like, quad 3, you know, they will be negative, and we know the values for pi over 6. So are you saying when you go clockwise, the positive negative sign will change?
No, what I'm saying is, if it was a point like this, I brought this one up before, if we wanted to know 4 pi over 6, you might get tricked into thinking that that's a pi over 6. But it's actually a pi over 3, because it's pi over 3 away from the x-axis. Do you see what I mean? And so you can either A, reduce the fraction so it's in the lowest form, or just think about how far that is from the x-axis. It's doing the same thing. Does everyone see that? That's the whole point of this, because if we're thinking about 4 pi over 6, you might think this is a pi over 6 version, but it's actually a pi over 3 type. And so you need to be careful about that and think about what can you reduce the fraction, basically, is what it comes down to. I mean, you know, I learned it doing this way. I think these notes kind of lay it out there if it's not clear. But you want to reduce the fraction, basically, is the short of it. And we won't have any problems with these particular ones. But you might have problems with other ones, so you just want to be careful about that. Does that make sense, Michaela? Are there other questions? I feel like I was going to say something else, and I don't remember. Yeah, I don't remember. Let me do at least one more, maybe ask you to try one. So minus 7 pi over 4 is the next one. And if we look at that one, we want to think about this as, if we do the shortcut way, right? This is minus 1 pi and 3/4. So we're going to go
halfway around the unit circle, and then another 3/4 of the way around. Or the other way to think about that is, we're 1/4 away from going all the way around. I hope one of those resonates with you. I don't know. Those are 3 different ways to say the same thing. Or worst case scenario, just think about counting out 7 steps of pi over 4, right? If you count them out, and minus means you go counterclockwise, right? I mean clockwise. And so we start here, we go clockwise, 7 steps of pi over 4. That would be 1, whoops, that's here. 2, 3, 4, 5, 6, 7. So this is 7 minus 7 pi over 4. Right, it's 1 step away from going all the way around. What's the t-bar? T-bar is this distance. Pi over 4, good, right. So let me write out the steps again. Number 1, t-bar is pi over 4. And so we know that our point is going to be a pi over 4 type. And so we say, all right, pi over 4 has the terminal point plus or minus root 2 over 2 plus or minus root 2 over 2. And again, I know that from the first page and building the unit circle and all that stuff, but also just because of this, right? Pi over 4 has this type of terminal point, root 2 over 2 comma root 2 over 2. And then we just choose plus or minuses based on where we are. And so we're up here in the first quadrant. In the first quadrant, x values are positive because we go right, y values are positive because we go up. And so we choose the positive ones. And so we say, since minus 7 pi over 4 is in quadrant 1, both x and y values are positive. And so our terminal point is the positive version of those. All right, very good. I don't need to see all this work, by the way. Again, at some point in the near future, you want to get to the point where you can think about 7 pi over 4 and write the terminal point down without writing any of this other stuff. I never want to see, you're welcome to show me, but I don't need to see any of that stuff. I'm just trying to make it clear how I'm thinking about it. Questions? Okay. Take a moment and do this one then. I think this will be the last one we do. I'll finish with this one and then we'll pick up with the last one on Wednesday. Just take a second to think about that one though. All right, what's the terminal point associated with 2 pi over 3? I'm just going to kind of start silently writing out the answer here because there's a little bit to write. Got just a minute left in class, so I'm going to finish this one up. So 2 steps of pi over 3 takes me right here, right? So t bar is this distance, and that distance is a distance of pi over 3 itself. And so remember, the whole point of figuring out what t bar is because now we know the form of the terminal point. So now we know that pi over 3 has the terminal point plus or minus 1/2, plus or minus root 3 over 2.
you guys just settle for just 1 second? Sorry. It's just really distracting in that case. We're in quadrant 2 here. We're in quadrant 2 where x values are negative, y values are positive. So in quadrant 2, points have the form negative, comma, positive. And so we use the negative 1/2 and the positive square root of 3 over 2. All right, that's how we think about that one. Problem to look at on this page, and that was t equals minus 13 over 6 pi. And remember, at the end of last class, we kind of thought about ways that we can do the shortcut of this. So this is walking 13 steps of pi over 6 in the clockwise direction. Or you could recognize this as minus 2 1/6 pi. And when you think about it like that, minus 2 pi is going all the way around the unit circle, and then 1/6 would be taking another small step. So it would be like we started here. We always start at t equals 0. It would be going all the way around the unit circle. That would be minus 2 pi. And then another 1/6 pi, or pi over 6, would take us to right here. So that point right there is minus 13 pi over 6. What am I looking for? And so now we want to figure out what that point is. And I'm getting the notes out from last time, because that's going to help guide us a little bit. Because now what we want to say is, we realize that this distance right here, this is what we're thinking about. That's our t-bar distance, right? The reference number is how far this point is from the x-axis. Our reference number is pi over 6. And so what that tells us is this point, minus 13 pi over 6, is a pi over 6 type point. And we care about that because we know, this is the last page, right? This is page 67. This is the previous page. We know that pi over 6 type points have this form, square root of 3 over 2, comma 1/2. And so once we recognize this as a pi over 6 type point, all we have to do is change the plus or minuses depending on what quadrant we're in. So for example, so what I just said, let me write down what I just said. So for pi over 6, we have the point plus or minus root 3 over 2 and plus or minus 1/2. And so what do we pick? Do we pick the plus or the minuses? Well, we're down here in quadrant 4. This point is in quadrant 4. X values are positive in quadrant 4, and Y values are negative. And so in quadrant 4, points have the form plus, comma, minus. And so we'll take the positive version of root 3 over 2 and the negative version of 1/2. And so our terminal point is positive root 3 over 2, negative 1/2. And so this is very important. I can't stress this enough, because everything in the rest of the entire rest of the semester, essentially, is very much based on the fact that we can understand the unit circle, how we get the points off the unit circle, and then what we can do with those points. And so this is like the first step of everything else we're going to do. And so I just want to emphasize that in case you just want to ask a question. I'd love to answer it. Do you guys remember this from last time? Or if you weren't here, do you want to ask a question? I'll be happy to answer it.
Yeah, I don't remember how you got the square root over 3 and the 1/2.
Yeah, good question. So back on page 67, this is the first page where we started walking around the unit circle in different increments, right? We had different increments. And the big takeaway from this section was this box up here. And it looks like I didn't star this box for some reason, but this is a kind of an important box. This box tells us when you have a pi over 6 type point, it has square root of 3 over 2 in the x spot and 1/2 in the y spot, and correspondingly with the other points. And so we need to remember these 3 values. And I know they look complicated, but what we mentioned last time is notice that this one here and this one here are opposites of each other. And so we don't have to memorize too many points, right? And pi over 4 repeats itself, right? It's root 2 over 2, comma root 2 over 2. And so I knew that this point had this form because it's a pi over 6 type point. Does that help? And I know this is fresh and you haven't had the practice, but once you look at a couple of these, you'll just start to, you eventually, hopefully, should start to just recognize and remember that pi over 6 has this type of point. Pi over 4 has this type of point, etc. Rachel?
I don't know if this is a good way to remember it, but I kind of, so I don't mess it up. I
Mhm.
was only thinking about the 6 instead of the 3, and I just thought of the 6 as alternating. So like each unit, it switches, and then it gets to 90 degrees, and that counts as a skipped one, I guess. My explanation sucks, but it's like,
I see what you're saying,
it's,
and then that sounds like that's working for you, and I'm happy for you. Yeah, so you should definitely come up with some good ways to remember that. And so Rachel's pointing out that every other pi over 6 you end up skipping because it happens to be a pi over 3 instead. I think that's what you're kind of saying, right?
yeah, like they just basically switch. So if you just think of it like 1, 2, then 2, 1, then 1, 2. I mean, that's not what it is, but
I completely agree. Did you want to add something to that, Nick?
I had a question, but I just figured it out after.
Do you mind just saying it in case?
It was just which quadrant has which form.
Okay. Yeah. So just to summarize then, the quadrant, we're always thinking about this as 0, 0, and so we can always move, if we move to the right, those are positive x values, and if we move up, those are positive y values, right? If we move down, negative y values, left, negative x values, yeah. Other questions? These are good, I'm glad you're asking questions, keep going. Keep them coming.